Ethereum developer community joining us today, introducing a really cool project he's working on, Scaffold, to everyone here who want to know more about how to build a really cool application on Ethereum and on Ethereum compatible chains like Polygon. So yeah, before Austin kick off his amazing workshop, let me just briefly introduce the background of this event. So basically, Polygon and DoraHacks are co-hosting a cool hackathon, the very first Polygon-centric global hackathon, Polygon-Grants hackathon that's ongoing right now. And also the very first Polygon-centric quadratic funding grant, where we use Matic token as the donation and voting currency. So yeah, Austin is basically here to introduce Scaffold, a powerful tool for every single one of you that might leverage to build your own amazing project. So without further ado, let's welcome the legend of Ethereum developer community, Austin, joining us from Denver, joining us from Colorado today. He obviously is a morning person. He's very excited.
That's right.
So
this got the coffee flowing.
Awesome. Just we do have Q&A session after Austin finished the main body part of the workshop. So if you do ask your question at the YouTube or Bilibili channels, and I will ask them for you to Austin. Yeah, please, Austin, go ahead.
Awesome. Thank you for having me. Hello, builders. I was just saying I'm an EVM compatible. I'm an EVM maximalist. I'm going to try to keep the YouTube up over here. Let's see if I could pause the video, but here, I'll mute it over here. I'd like to see the questions flowing in. If you have questions, shoot them in, and I'll try to kind of get to them as we go. I think first of all, happy Bowtie Friday. Thanks for being here. Good morning for the people on my side of the earth. Good evening to the people on the other side of the earth. Thanks for being here. We're going to talk building on Ethereum and EVM compatible chains. We're going to talk about the tooling, and we're just going to kind of dive into it. I think I'll just share my screen and we'll go if everyone's good with that. Here we go. Let's get a screen share going. Okay. So if you are starting on Ethereum, if you have questions about what the heck is Ethereum, what's an NFT, what is going on, Ethereum.org is a great place to get in and check it out and kind of get a lay of the land, right? Understand how to use Ethereum, get a wallet, get ETH, and then learn the why, right? Why Ethereum? Why decentralization? What do we even need decentralization for? Why are NFTs so cool? What is decentralized governance and what makes it so special? And why are people really getting into this? And then ETH2, and I have my little staking node back here. I don't know if my audio, oh yeah, it is. You can probably see this. This is my ETH2 node right here running. If it starts sucking up too much bandwidth, I might have to shut it off during the presentation, but learn about ETH2 and learn about the merge to proof of stake. And then it's time for developers to dive in, right? There's a bunch of tutorials and documentation on ethereum.org. But I'm going to go to Learn by Coding first. Two really good tools, Remix and ETH.build. So Remix gives you a browser-based Solidity editor. It's a great way to grab some Solidity and paste it into the browser and tinker around. It feels to me more like a professional kind of complicated tool that you can do it's less approachable, I think, to newbies. But as a newbie, you can just open up a browser and go to Remix and start tinkering with Solidity. So maybe it is friendly to newbies. It just feels complicated. But anyways, ETH build is the other option. And ETH build, I'm partial to because I created it with help from a bunch of developers, but I use it for teaching, just for teaching the fundamentals, really. Just understanding hash functions, key pairs, encryption, blockchain, all the way to smart contracts, a lot of like filling in the details of the fundamentals. You can hit ETH build and pick up that knowledge there. And then you can click the little build button and just start tinkering. You can get in here and we can talk about, ooh, what was I doing here? Something fun there. So here's a smart contract, and you could drag and drop an ABI and it parses it into an object, and then it plugs it in here. And then here's the mint function. I think this is maybe loot. I think maybe this is the loot contract. I was trying to mint something or something, but let's go ahead and get rid of those. The one thing I want to show real quick is just some real basics of how to interact on an EVM compatible network. Basically, it all starts with this private key, right? And possibly you could have a mnemonic that's more of a 12-word seed phrase, and you could generate that mnemonic, and then that could make multiple private keys. But here we go. I'm kind of generating a 12-word seed phrase, deriving that private key, and then getting the address from it. And this really shows that the powerful thing you can do with this key pair is now you can sign and you can recover messages. So anyone with their key pair can sign a message. It can go across the network to anyone, and then anyone on the other side can recover that message and see that it was for sure that person that signed it. And if anything was tinkered with across the network, that signature is going to break down and it's not going to work. So that property of signed messages works really well for transactions. I can say to and from, and I can sign and I can send it. Yes, you are free to ask questions. I see the first question in there is, are we free to ask questions? Drop them in there. If they're quick little one-liners, I'll probably be able to see them better. I see like a paragraph and it's hard for me to parse that while I'm going, but I will be watching questions in the YouTube. So you keep the key pair, right? Your key pair is like your access to this world. You have to have a key pair, and you got to have a little bit of the currency to pay for gas, and then you're set free on that EVM network, and you can do whatever you want. You can make all your transactions, sign them, and send them. Eventually, you'll get to blockchain, right? With ETH build. Let's go see what the current block number is on the Ethereum mainnet. It's there it is. There it is. There's the current block. Or maybe I could get like my balance or something, right? Like I could plug in an ENS. Oh, could I do ENS? Oh yeah, I totally can. Watch this. So I'll do my name and then I'll do the address. And if I put in Austin, let's see if this works. Griffith.eth, and hopefully that resolves to my address. And then if I call this, I should get, there we go, there's my balance. That's really cool. Okay, so eth.build and remix are great for tinkering. They're great for kind of just like getting in and testing your assumptions and trying things out. But then it's time to upgrade, and it's time to get your tools set up locally. And this can be quite a challenge. Getting your Web3 stack ready to go and having it all up and working without anything falling over is quite a challenge. And there's a lot of great tools to help you do this. But the thing I'm going to zoom in on is Scaffold Eth. Scaffold Eth is a combination of Ethers.js, Hardhat, and then create React app, basically. And I've glued everything together. I with a lot of help from a lot of other developers, we've glued this together in a way where it works out of the box, and you have a dApp that just works, and you're allowed to start tinkering with the Solidity, and you'll see it change in the front end. And we'll get to that in a second. But with that dApp toolkit, not only do you have a working dApp, and any of those little issues that you would have setting up your own environment are solved for you, but then what we found is with these templates that we're creating, once you have this template system, lots of other people are creating lots of other templates. And now there's like 250 some branches. There's hundreds of branches of this dApp starter kit for other kind of dApps. So NFTs or DAOs or DeFi. And we'll get into that in a second. But if you just Google Scaffold Eth, or you go find it here on ethereum.org. I'm going to Google, oh man, what is that doing? Okay, get that browser out of here. None of that. Let's get a, here we go. Let's do this. If you Google Scaffold Eth, you'll find scaffoldeth.io, and it'll take you right to the repo. Everything starts in the Scaffold Eth repo. And you'll clone down Scaffold Eth, you'll CDN, and you'll yarn install. Let me see if I can zoom in on that so you can see it. And that's basically it. And then you'll deploy your contract. So I've done that ahead of time just because it takes a while. So this terminal right here is my Hardhat node. This is like my backend. I'm going to do a lot of analogies here for Web 2 developers. Hardhat is like my backend. It's a local blockchain, and it has a bunch of wallets that are loaded up with a bunch of local ETH. So I have my own blockchain, and I have a bunch of accounts that are super rich. Then the next thing is my React dev server. So this is my front end. This is where I can see things and I can interact with them. And then this is my deploy terminal. What I'm doing here is I'm just firing off these yarn deploys. And what that's doing is it's compiling my template contract. It's compiling my smart contract. It's deploying it to my backend. And then it's taking the artifacts, the address and ABI, and it's injecting them into the React app. So you get this nice little dev loop. And I'll show that off now. Let's get rid of that. Let's get rid of that. Here's the most important file to start with. So this is in packages, hard hat contracts. This is your smart contract. This is just a nice little example smart contract. And then your front end is going to be at localhost 3000, and we'll see that come up here. All right, we are off to the races here. And let me show you what I mean by, let's just add some exclamation points here, the dev loop. I'm just going to make a small change to my, whoops, didn't mean to close it. Just going to make a small change to my smart contract, add some exclamation points here, and then I'm going to yarn deploy. And let's see how this goes. There we go. So I deploy my contract. Now watch over here. See how that updates? It hot reloads, and we see the exclamation points going in. And it didn't actually hot reload a month ago. It would actually reload the page. Someone got in and made it hot reload. I don't know. Open source, bro. I love everyone working on Scaffold Eth and helping me out and building out this ecosystem. And we'll get to kind of how to help out and contribute later. But hot reloading is really neat. So what we have is we have a smart contract over here, and we have a string purpose that we're storing, and then we have some function that lets someone update that purpose. And if we go ahead and just let's call the set purpose function over here. I want to show this console log working too. Over here in your backend, in your hard hat node, if I say hello world, okay, this is going to fail. I know this is going to fail. It's going to throw me an error. It's going to say, hey, you don't have enough money. Oh yeah, we've got to have gas to get on the network. So technically I could grab this and I could go down to this faucet down here and paste it in, but there's this nice call to action here in the top right. If I click that call to action, it's just going to give me like what does it give me? 0.01 ETH. And I can use that 0.01 ETH for gas. Now watch what happens when I hit hello world. Boom, nice. Okay. There's that console log. We get a nice feedback and we can actually get into this smart contract. And while you're in there building your Solidity and things aren't making quite enough sense, you can always throw in this nice little console log and you can get some information over here from your hard hat node. Okay, so when I did this, there was no MetaMask prompt there, right? I just click the button and it works, right? What the heck is going on there? Well, there's a burner wallet in Scaffold Eth, and I'll show that. Let me open an incognito window, and let me go to localhost 3000. And you'll notice that on page load, I'm going to get a new account. See how this account is a little different than that account? Let's do that again. Let's do that again. Let's bring up another one. And so that private key is stored in local storage, and we can grab some money from the faucet. We can grab this dude's address. We can go over to the wallet and we can send this dude $10, right? So, and you can see there's a nice blocky preview. You can see that this thing can do ENS resolution, right? If I want to go to vitalik.eth, it should resolve his address and let me I'm going to send $5 of my testnet ETH to Vitalik for some reason, okay? So Scaffold Eth comes out of the box with this nice smart contract. This UI here that's going to auto adapt as you add and remove things from your smart contract, but also these burner wallets. So when you land, you get this nice, quick, smooth interaction, and you can just push buttons and go, and you can tinker with your smart contract. Eventually, you'll probably connect your MetaMask or some other stronger wallet, but I wouldn't recommend doing that until you're deploying this thing to test nets, and we'll get to that in a second. But let's dive in, and let me show you. Let's see, do we send some? Let's make sure we can send some. Let's grab this guy's address. Let's go over here. Let's paste this in, and let's send our remaining, like $20. Let's make sure the money leaves this account and goes to this account just so we see it happen. There it is, 59. Okay, cool. Okay. Now, what I preach so often is the ETH dev speed run. So if you're getting up to speed with Ethereum, if you Google ETH dev speed run, you'll grab this awesome Medium article, which I'm totally just gonna YOLO into the chat. Oh no, I can't. Wait, what did I do wrong? I think I have to create an account to log into the chat. I can't just like anonymously drop something. Okay, so I can't do that. But if you just maybe I can even paste it into the private chat and someone could YOLO it in. I have no idea. But if you just Google ETH dev speedrun, you're going to get this speedrun. And it says it all starts with tinkering with Solidity, get Scaffold ETH up and running, and then focus on each one of these steps, each one of these concepts. And the best way to learn these concepts is to just click into here and just copy and paste one. So let's learn how this address works, right? I'm just going to take this address, I'm going to paste it right into my contract, and I'm going to hit save, and then I'm going to deploy. Now let's watch what happens over here on our front end when I added this new address in. There it is. There's that new address. So now it's like part of my smart contract and it shows up and it auto adapts. I think what I want to do is steal this guy's address and paste it in. And I think I'm going to call this owner, right? And this could be anything. This could be, I could name it me. I could name it anything. It's just an arbitrary variable we're storing in our smart contract. But let's go look now. If I set me as the owner and I deploy that, we should see this change to this guy's address, and we should see a new contract get deployed. And there it is. It's that fast. Yeah, that's your iteration loop. We're tinkering, we're trying, we're testing our assumptions. So what can we do here? Now that we have this owner, we have this set purpose function. Anyone can call this set purpose function and update it. Let's do something. Let's build like a little attestation machine, right? Let's set this up. So we're going to create a require statement. Okay. And a require statement is like writing a rule in Solidity. It's super valuable. It's your way to set rules, right? We can set access and we can set rules here. What we're going to require is we're going to require a certain condition, right? And we're going to require that the message.sender is equal to the owner. And what that means is the message.sender is whoever's getting into this function. So it says whoever gets in here and calls this thing, they have to be equal to the owner, or we're going to yell at them and we're going to say not owner, and we're going to kick them out of here, and they'll never get in and be able to call this function. And let's go deploy that and let's make sure it works. So we just turned this little, it was kind of like, what was it? It was a smart contract that let anyone just update it willy-nilly. Now we updated it so it's more like an attestation machine where me as the owner of this account, right? Whoever holds the private key that derives this public address is the only one that should be able to get in here and call this this set purpose. And let's go test it out, right? So if I say hello, this should work, right? We should get the hello. Now, how do we test the other case, right? We'll bring up an incognito window. This will be our bad guy over here. Okay, bad guy, purple guy, grab some fake money from the faucet and say hello, question mark, and this should hopefully fail. There we go. And we get a nice message from from Hard Hat that it failed, saying not the owner. So our require statement worked perfectly. We were able to require that only the owner could get in here and set this. Okay, this is a good start. Let's see. Double checking questions real quick. I think we're good. I don't think, if I missed a question, repost it there. I think we're good here. What I want to do though, so this smart contract is kind of a one-player thing. It's basically whoever owns just that private key can get in here and access this and set this value. So it's a great attestation machine. Maybe if you were Preston and you were releasing versions of Prism for ETH2 and you wanted to put the hash of the repo up on a smart contract so everyone knows that they're getting the correct code, this might be a cool way to do it. You deploy this contract, you let everyone know about it, and then every time you do an update, you send that hash in there, and everyone knows that all they have to trust is the code, and they trust that the person who owns that private key is signing these hashes and releasing these versions of Prism or something like that, right? I don't know. I don't know if that's even a good use case. It would be expensive probably, but here we go. We basically have this one player set purpose. What you need to think about is sort of what Ethereum really looks like, right? And what it looks like is not chains of blocks. It actually is thousands of machines all the way across the network, and they're all communicating peer-to-peer, and they're all coming to a consensus about what those chain of blocks looks like. And within those chain of blocks, it's not just transactions sending to and from, its execution, right? There's an EVM that each one of those machines holds. This little machine right here holds a little even smaller machine that does really simple computation. And everyone takes all of those transactions in the block and they run them through their EVM and update the state of that little computer. So it's this, to be honest, it's the greatest massive multiplayer RPG ever created. And if the recent stuff with loot and all those cool NFTs doesn't prove that, I don't know what will. But let's think of this more like a massive multiplayer RPG, okay? And just to zoom in on that a little bit more before I even go farther, I want to talk about cron jobs. In Web 2, you would stand up a server and too many people would hit it, and you'd set up a second server and you'd provide redundancy. In Web 3, basically the network is the redundancy. There's thousands of nodes that all hold your contract. Every time we push this contract up, every time we update every time we do this, I'm going to say, hello, number 2. I'm crafting a transaction. It's going to the mempool. I'm bidding with my gas price to get that transaction mined. And once that transaction is mined, every node, thousands of nodes on the network, every node on the network says, oh, he just set that value to hello 2. And I read through here and I say, oh, he's the owner. He can do it. Okay, he's setting it. Okay, I'm updating it. Every single node on the network is updating that value. And that's why it's expensive to store on that layer. So cron jobs, if you think about it, you can't just run a cron job. You can't just tell this contract, like every night I'd like you to increment this value. You can't do that in a smart contract. Someone's got to poke it. Someone has to poke the smart contract. So if you think about it in a way, it's sort of like this adversarial network. And if you want to get a cron job to work, the way you do it is you incentivize folks. You make it so once a night, anyone in the world can get in here and poke this thing and update the thing that you need updated. And when they do, you'll throw them $30 or something. So you figure out a way to incentivize folks in an adversarial network to play the game that you want them to play. You need to think mechanism design here. Okay, with all that, sorry, that went down a giant tangent of Web 2 and cron jobs. But this smart contract is very centralized. And what we need to not centralize, it's on a decentralized network, but only a single person can get in here and update it. We want to think massive multiplayer RPG. How do we turn this thing from an attestation machine into more of like a vending machine that anyone can get to at any time, right? And it's a small change here. What we'll do, instead of requiring that you are a specific person, we're going to require that you send in some money. Just like a vending machine, we're going to ask you to pay 0.001 Ether. Okay. And there's one other thing we need to do is we need to make this function payable. All right. Now let's go ahead and yarn deploy that. We've changed this thing. It's no longer a smart contract that the owner can get to and set the purpose. It's now a vending machine that anyone in the world with a key pair and some ETH can get into and set the purpose. So I can set it, right? And I can get in here and I can pay my 0.001 ETH, and we'll get to that in a second. But someone else can set it too, right? Let's go to localhost. Let's bring up this other jabroni here, pink guy. All right, pink guy should be able to say, I'm pink too, woo. And pay their 0.001 ETH and send that in. And then anyone on the network can read and see that value. So this is much more multiplayer. This is much more like a vending machine. Okay, cool. Here we go. So we've built our vending machine. We've paid some money. The thing that I want to dive into a little bit is this right here compared to this right here. So again, this machine is a node on the network, and this machine has a little machine inside of it that is the EVM, and all transactions go through that EVM. And so that EVM, the more complicated it is, the harder it is to run. So if that EVM has a bunch of complicated floating point math, then it's going to be harder for people to run it locally. So we want the EVM to be as simple as possible. We want it to be like this little embedded machine, right? Like we're writing these simple apps for it. So when you pass something into the EVM, it needs to be in way. And way is, let's see, one way. Let's see, can I zoom in? One way equals 10 to the power of 18. Whoops, other way around. 1 ETH equals 10 to the power of what? 18 way. So we do this trick in the EVM where basically we take all the numbers and we divide them by 18 decimals, assuming that that's the decimal point, right? So if I say I have, 0.1 ETH, that would be 10 to the 17 way. And so when we pass it into the machines, we've got to do this right at the end and turn it into way, but it's actually the same thing. And us for humans, we like to see it like this, but the humans need to see it like this. So there's this quick little thing that happens here. And if you're a developer, I make you do it. I make you actually like get in here and say, okay, yeah, I want to do that. But then I make you hit this button and see visually that you're converting it to way and then submit it. Obviously, when you're building something for someone else, you're going to carve this stuff out and you're going to build an example UI and you're just going to let them say hello and set the purpose, or even have a simple button that I think, let's see, one of these, there we go. That one actually set the purpose. If we go back over here, paying for this one, it set the purpose and paid for it. Just a simple button that did that, right? So there's an example UI here in Scaffold Eth that helps you figure out how you could build a better UI. So here we go. Let's see, where's the paying for this one, right? There it is, right? So here, let's just look at that line real quick. That's a nice little, so we have a transaction wrapper in the front end, and then we go to write contracts, your contract, set purpose, and we set the purpose to what we want. And then we throw in this override here where it sends a little value to the contract. So there's the button right there that will talk to our contract and set the purpose and pay some money to do that. Okay, awesome, awesome, awesome. So you have figured out how to tinker. You've figured out how to build this vending machine in the sky that anyone can access and pay money to use. You've got, let me also do that. There we go. You're ready to kind of learn Solidity. You're ready to kind of build things. Follow this this curriculum here. It's easy. If you're a Web 2 developer, I've already explained cron jobs are weird. I've already explained redundancy is weird. Like your back end is this whole network, and you're programming a very simple code, and it's expensive to write, right? But reads are super accessible. You can ask any node in the network the value of a smart contract and get that back. So you as a Web 2 developer, you should be able to dive in and just pick this up very quickly. The picking up the Solidity is like the top of the Dunning-Kruger, where you think you know everything and you feel like you can build anything, but then you need to kind of go on this tour of duty where you learn all of these different concepts. Okay, and let's just look at, so first of all, let me pick up, let's just say mappings. Let's say mappings are the next thing here. Let's figure out how a mapping works. Let's just grab a mapping out of here. We can kind of see, if you're a decent programmer, you can kind of see what's going on here. It looks like there's this storage map, and they've got some get and set and remove functions. And a get just returns the value, and a set lets you set, you pass in an address argument and lets you set it. Okay, so this should be pretty clear, but let's get in and tinker with it, right? The best way to find out is to have this. Okay, so we pasted in my map. And now if I do a yarn deploy, we should see my map show up in our front end. And that's not right now, there's my map. And so we could pass any address into it and it's going to give us some value back, but they're all zeros right now. So what we want to do, let's call this balance instead. Okay. And then let's put it up here just to make it clear. And on the constructor, and let's put the owner up here too. Just clean up the code just a little bit, right? Okay, so what I'm going to do just for fun is I'm going to set the balance of owner to 100 Ether, right? Yeah, let's just do 100 way. It's easier just to show things in way, right? So this is way, but I don't have to type it. So the balance of the owner is going to start at 100 way. What I'm going to build here just really quick is just show how to build a decentralized currency, how to build a token. And we're just going to create a balance. We're going to make sure, this dude's balance is now 100. Now, what do you need if you want a token? You probably want some function to transfer, right? And some address to, and some uint 256 amount. We'll make it public. And what happens in a transfer? Well, there's going to be one of these require statements, and you're going to say, okay, so amount has to be less than or equal to your balance, right? So we would do balance of message.sender. And if not, we'll say not enough. Again, like you didn't have enough money, and we kick you out of here. But if you do have enough money and you make it past this line, then what do we want to do? We want to send some money. Let's see, let's take the money away from the message.sender, right? So we'll say balance message.sender minus equals amount. Whoa. And we'll say balance of the to address will plus equal the amount. Simple programming, but we just created our own decentralized digital currency. You obviously will have some extra things, and we'll get to inheritance in a second. You won't write your own transfer function. That's just not the way to do it. But if I hit send, I can see that I have 100. Let's bring up a new character in this game. Who's it going to be? Blue guy. Okay, blue guy, grab some gas. What we want to do is grab his address, and we want to use this transfer function. And let's send 25 of our tokens. Remember, that's 25 way. It's not 25 ETH. You would hit this if it was 25 ETH. We're just going to do 25 way, and we're going to hit send. And there we go. So now this dude's balance is 75. And what if we grab this dude's balance and check it? It's 25. All right. So we were able to create a currency with balances for everyone and transfer functions so people can send them around, and set a rule to make sure that someone can't transfer something they don't have. That's basically what we need to create a token, right? And I think if we, and what I was looking at there, most importantly, is how to learn how a mapping works. What I'm looking at there is I'm going down this list and I'm learning mappings. And the way I'm learning them is to go through this curriculum, find these things that I'm trying to learn, and paste them into Scaffold Eth and deploy it and see how it looks on the front end and tinker with it and poke at it. So you'll go through this whole curriculum here. Whoops, I think I lost it. Let's see. Let's go back to Scaffold Eth, the repo. You'll go through this curriculum and you'll learn all of these things. The one I wanted to point out is inheritance. In inheritance, you can, instead of setting me up as the owner and then requiring that I'm the owner here, what I can do is I can import OpenZeppelin's ownable library. And then I can say this contract is ownable. And then I can just say over here, we're doing payable stuff now, but let's say we want to go back to the single person can update things. What we do, might as well pull all this stuff out here too, is so I made it ownable. I took out this require statement, and I'm going to say only owner here. So this is a modifier, and you'll learn modifiers. But this allows me to have an ownership pattern where I'm going to own this thing, and only the owner can set the purpose. But I don't have to write all that stuff. I'm just going to inherit it from OpenZeppelin. Let's see if this even deploys. I feel like this might have a, yeah, I think we've got the latest version of OpenZeppelin. Yeah, so you could do something like greater than 0.6.7 maybe, and it's probably going to complain about something else, but let's see what it does. Oh, the constructor needs to be public. Okay, cool. Okay, now we should be good. Let's see. Maybe I just wanted to show inheritance here where I'm not writing any ownership stuff. I'm bringing in the ownable, I'm inheriting it, and then I'm saying only the owner can set the purpose. And then if we get over here, we should see that our contract has a couple it has a transfer ownership function. It has a renounce ownership function. The owner is actually this account, the faucet account. So the first account on our hard hat is doing the deploy. Okay, so we've inherited it. This guy's the owner. He can transfer the ownership. We can inherit all sorts of stuff. Instead of building that token with those transfer functions, you should just inherit the ERC20 from OpenZeppelin. Go look at the OpenZeppelin contracts. That's Scaffold Eth in a nutshell. You can pull this up. You can have this nice environment where you can edit your Solidity and you can see it change in the front end. You can tinker through all of these concepts and you can learn Solidity. You can get up the Dunning-Kruger and feel like you can conquer the world because you understand Solidity. And it's actually pretty easy for a programmer to pick up and start building. And then you have this moment of like, whoa, I can build anything. I can build, I'm a programmer with a Turing complete language running on top of a blockchain. I can build any blockchain application I want. And that's the power of Ethereum. That was the point. That's the point of, we'll take care of the blockchain, you take care of the code, right? As a developer, as an innovator, this is where you focus, and the network handles it for you, and people only have to trust your code. Okay, so you've gotten that far, you've gotten through the Solidity. What do you do now? You're at the top of the Dunning-Kruger, you can build anything you want. This is where that speed run comes in. So the speed run takes you through learning Solidity, but then it has a ton of examples of really interesting and important builds in Ethereum that help you understand and get context for what works on Ethereum and what doesn't, and what are some of the gotchas. We've already talked about no cron jobs. We talked about it's super expensive to write and super slow to read. It's asynchronous. It's like an asynchronous database, right? There's a lot more though. There's some interesting things there. So scrolling through, you'll want to check out this simple NFT example. You don't have to write any code. In this case, you deploy an NFT, you mint a bunch of NFTs, and you send them around to multiple accounts. This just gets you started. But what's cool is it's a freestanding NFT app, and you can get in here and you can look at your collectible. And here's the entire NFT contract right here. Thanks to Open Zeppelin, we're importing basically everything. All we need to do is just write how this mint is going to work, right? And in this case, we're not doing anything fancy. We're incrementing a variable and minting the collectible. So the very simple example, but having all of that freestanding, having a nice README to walk you through it is going to get you dangerously close to having any kind of NFT app you want. And then from there, you can kind of extend it, right? And in this case, we extended the contract to mint NFTs, but do it in a way where there's a gallery, and the artist just deploys the contract with the NFTs listed, and the buyer comes in and the buyer pays the gas. So in this one, it's more of a gallery of unminted NFTs, and you mint them. And all we did was take the simple NFT example and extend it just a little bit. And this is something interesting to dig into, is as we have these templates and we have these small changes and iterations that we add new things to, all of a sudden we're building out this ecosystem of starter kits. So there's tons of starter kits on Scaffold Eth. Jump into that simple NFT example first, but then there's challenges. Once you're ready, once you've got mappings figured out, jump in and take on the decentralized staking challenge. This is a smart contract to get a bunch of people that don't agree all to either put their money in and lock it up, and there's a time period. You have to get your money locked up by a specific time, or it switches into a withdraw pattern. So it's kind of like a state machine. There's like this withdraw period, or there's this deposit period, and then at some timestamp, it either goes into execution mode where it moves on to the next contract with everyone's money, and it continues on with something else, or it reverts and everyone can withdraw their money, right? It's kind of this state machine. And so get in here and learn this, go through this challenge. You'll have to write Solidity here. Now, this is like where I'm not writing the Solidity for you. You've got to write your own Solidity. You've got to write your own smart contract. But this is a fundamental piece of Ethereum, is learning how to build this specific contract, because it teaches you a few things: payable functions, timing, the withdraw pattern, and just like the nature of building a massive multiplayer game for adversarial parties, right? And that's what Ethereum is good at, is innovating on that layer. Okay, so take on challenge 1, then take on challenge 2. In this case, you'll mint an ERC20, you'll mint a vendor, you'll set it up so the vendor sells the ERC20. And then if you sell the ERC20 back to the vendor, if the vendor buys it back, you'll learn the ERC20 approve pattern. Okay, then randomness. Randomness is super tricky on chain. You need to learn how to get randomness in. There's one way, and it's commit reveal, but the UX isn't great. And you need to learn why randomness, first of all, why randomness is so hard on a public deterministic blockchain. But then once you know why, start to figure out how to generate random on chain. One way is with commit reveal, another way is with an oracle. And that would be like Chainlink's VRF does good randomness. You send things, then they call back to your contract. Get into it and learn it. It's really cool. But also just learn about oracles. You can use oracles to pull data from APIs into your smart contract, but you need to be thinking like, this smart contract is super decentralized. This API is not. There has to be some, like, maybe you pull from a bunch and you average them. Like you figured that part out. Go look at, and I think Chainlink probably does some of this, but go look at oracles, understand the oracle problem. And then DEX, build your own DEX. And this article will take you through building your own DEX. It's really a simple decentralized exchange is really pretty, just a simple amount of Solidity. You can get in, and once you build an exchange where people can exchange tokens for ETH in a smart contract, and the TLDR is you keep reserves, and you swap between those reserves, and you leave a tiny little bit behind, and that is the fee for the liquidity provider. Then side quests, get into bonding curves, build your own swap, like basically build your own Uniswap app from smart contracts to front end. Then look at lending. Lending is super important for DeFi. Build an app around Aave and some of their lending stuff, and learn how to like build a leveraged contract that will leverage up. Don't do it on mainnet. This is all for education, but there's a lot of DeFi stuff you can learn. And then get into signed messages. Going all the way back to that private key where we could sign a message and we can send it and we can verify it by the other person. This works great off chain. Like I can sign something and send it to you. And this is how state channels work. But you can also do this on chain. I can sign a message and I can give it to a relayer, and the relayer can pay the gas. And my signed message will be recovered inside my smart contract using the EC recover or OpenZeppelin's ECDSA library. And they're kind of called meta transactions, but I think they're kind of phasing out. We're bringing in something new. We'll see how that works. But multi-sig wallet, build your multi-sig wallet, and then build a signature-based multi-sig wallet. And that's like if you can go through this speed run, you can show any recruiter in the space that you've finished all this stuff, you understand all these concepts, and you built a signature-based multi-sig, you're going to get hired at like hundreds of companies in this space. So this will get you up to speed and get you ready to go. Now, let's say you've got all of that. You're building your production app now. You're at the point where you've got something created that you really like. How do you deploy it? So I could run through Scaffold Eth and deploy it here, but I think an even a more interesting example would be to move over to, let me make sure I have everything killed here. Let's move over here. Let's bring this browser with us. And what I have here is the Polygon tutorial. So I'll do a yarn chain, right? We'll fire up our local chain. Actually, I don't even think I need a chain. I think this thing is pointed at Mumbai, and we can find out right here. Yes, it is. Okay. So all Scaffold Eth apps are shaped the same. You know where everything is. You know you've got your hard hat contracts folder. That's where you look for your contract. You've got this deploy folder. This is where your deploy script is. You've got your hard hat config. This is where you're configuring your networks and your compiler version and stuff like that. Then into the front end, you've got your app.jsx. And here we have the network that our app is talking to. Okay, so let's go ahead and yarn start. Let's fire up that app. Basically, this is going to be an app that's pointed at Mumbai, and it'll take a little bit to come up. But what we're going to do is we want to deploy. Let's just go to Matic. I feel like I have just a little bit of time. Let's go all the way to Polygon with one deployment. Let's put like an NFT out there. Let's see, how are we going to do that? So we have to let this load up. And while we're waiting for that, there we go. There it's loading up. There it is. Okay, so we're actually ready to deploy to Mumbai. And let me share this. So if you go to Scaffold Eth, if you go to the Scaffold Eth repo, I think it's Matic, not Polygon. Sorry, it should be Polygon. Matic NFT tutorial is what it is. I'll paste that into the chat in case anybody wants to pass that along. Go to Scaffold Eth, search for Matic. If you search for Polygon, I think there's another one that we're working on. They will say Polygon soon, I think. Yeah, there it is. We're working on a gasless one with Biconomy, and it's almost done. So here's a preview. There's another branch there if you want to do gasless NFTs on OpenSea using Biconomy and Polygon. That's there. But let's just roll back to just the Polygon demo. Here's what we're going to do. We've got everything working. We've got our app working on localhost, and we're ready to go pro with it, right? So I'm going to set my network to Matic, and I'm going to create yarn generate. So I'm going to do a yarn generate. And by the way, this is all in the repo. Let's see, how do we go find that? Let's go find it. So I'll just follow the instructions exactly instead of getting too far ahead with doing it off the top of my head, right? Let's just follow this thing. Oh, and there's a great speed run to see Shannon and I like whale through this. We had a lot of fun with it. But here's you clone it down, you CDN, you make sure you have the right branch, you do a yarn install. Okay, now here's where we are, yarn generate. So when we're deploying locally, our hard hat node is paying all the gas to deploy our contracts, and our hard hat node, the first account in the hard hat node is kind of the owner of those. You don't have an account that'll just deploy contracts for you for free on a public network. So on a public network, we're going to have to create a deployer account. And the way we do that, it's right here. It's just yarn generate. Okay. So if I run yarn generate, it's going to create an account for me. And if I'm just going to do it again. Oh gosh, what did I do there? I'm going to get out of here. Okay, let's do one more yarn generate just to see, like, what it does is create a 12-word seed phrase, and it keeps it in the repo, and it's ignored. So don't commit it to GitHub. Be sure not to commit any mnemonics, but it's the whole dev stack, and the ignore is already set up for you, and it's already ignoring this file. So you would have to do something pretty dumb to release this. And that's the thing. It's like, we try to make it as safe as possible. We try to make it all work out of the box so you don't make those silly mistakes. Okay, so we've generated an account. And what I need to do is send this dude some Matic, I think. Let's see. Let me jump over to, oh man, so many networks. So many networks. Oh, I wonder if the front end can just show it. Jump over to Matic. Oh man. Wait, will the front end just do it? Let's see. There's a chance that the front end will detect that it's okay. Nope, it's still not. And MetaMask doesn't render on second monitors. That's so nice. Okay, there we go. Matic. Let's see. I think I selected it. Yes. Okay. Is it there? Do I have Matic selected? I have an account. Okay, let's just use this account. Cool. So I have 200 Matic on this account. Our front end needs to be pointed at Matic. So we have our back end ready to deploy to Matic, but I'm actually, yes, let's leave it right there. Okay, let's continue on where we are. So we've generated an account. We've pulled down this Matic tutorial. We've got a collectible right here ready to go. It's got some artwork that I've already created. This mimics your Scaffold Eth. It's going to work on every other Scaffold Eth the same. What we want to do now is fund this so we can deploy on Matic. So I'm just going to use my MetaMask for now, and I'm going to send, I don't even know, maybe 0.1. 0.1 is probably enough. And there it goes. Okay, so here in a few seconds, our deployer will have enough money, and we can do a yarn account, and we can double check that. And it gives you a nice little QR code. So if you have an instant wallet or a burner wallet on your phone, you can just point it at that QR code and send some funds. It's going to look through all these different networks. There we go. We do have our 0.1 Matic. All right, so we are ready to deploy. I'm just going to do a yarn deploy. Let's YOLO this thing and see what happens. Deploying to a public network. Happy Bota Friday. Boop, 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 boop. All right, awesome. So our contract is deployed. We've compiled and deployed our contract. It's on Matic. Now we want to use our app to access it. So in the app.jsx in your front end, we're going to change this to Matic. And now our app should, there we go. It kind of hot reloads. It points to Matic. I'm going to go ahead and connect my MetaMask now because we're on a public network. If I want to go look at the contract, I can. If I go debug contracts, I can see everything I can do on that. Who's the owner? Oh, that would be that deployer account, right? That's what it's supposed to be. Oh, it's deployer account right there. Yeah, that's probably who the owner is. Nope, it's not. I wonder, I must be sending it. Let's see, in our deploy script, do we transfer the ownership? I don't know. Anyways, our contract is up. Let's click on it. Let's go look. There it is. It's on. So other people have used. Why did it do that? I'm not sure why the deploy script should have used the mnemonic and it didn't. Anyways, it's deployed. We've got it. Let me do another yarn deploy. I feel like it's reusing some. Yeah, it is. Oh, what a turkey. It's reusing one that I've done before. Okay. Wiggle wog, yarn hard hat deploy. Why does it reuse stuff? All right. -- reset like a peasant. And here we go. Now it's going to redeploy our contract. It's going to pay. We should be the owner. No caching of smart contracts. Come on. All right. This should take a couple seconds, and then we should have a contract deployed to Matic. Oh, man. You know what I didn't think about is gas prices. Do you have to up your gas price to get a transaction to go through? Oh, looks like it did. Okay, cool. So there is our transaction. Now, for sure, this dude should be the owner. CD3, that's us, right? If I do a yarn account, that's our deployer. Oh man, that is that's a little trick right there. That caching of that smart contract, reusing it, that hung me up. Okay, there we go. So we've got our owner. It's correct. If I click on this, it's a fresh contract that was deployed 31 seconds ago. All right, so now we've got our NFT contract and we've deployed it. Then we've set up our app and we've pointed it at Matic. We've got our front end ready to go. What I want to do is I want to copy my address and I want to get into this mint script and I want to paste it in. And what this is going to do is it's going to mint a bunch of collectibles with a script and they're going to show up on Matic for me. So if I do a yarn mint, here we go. This is going to use my deployer and it's going to mint these and send them to AustinGriffith.eth. And we should see them start to show up in the front end, depending on how long it takes to parse events. Oh man, come on, show up in the front end. Are we seeing transfer events yet? No, we're not seeing anything. So it's got to parse the events, and perhaps that's a slow thing from the RPC. Let's see. Do we have transactions going to the contract? No, not yet. Okay, so we're waiting for those to mint on Matic. Let's see. I mean, the transactions, let's see. Can we see? I should have console logged. There they all are. It just took it a little bit. There they are. Okay, so there's all of our collectibles on Matic. If I go to OpenSea right now, I'm going to see these on the front page of my OpenSea. This is a total secret weapon that no one knows about. You can mint these things fast and cheap on Polygon, and they show up in your OpenSea. It's going to cause a whole explosion of weird things to get built. But here we are. And let me just go, you know what? Let's just send one of these. Oh no, this is going to show up in Vitalik's OpenSea. I'm going to do it. I'm sorry, Vitalik. I'm sorry, Vitalik. Here it goes. I'm sending you this Buffalo transfer. Yes, I do want to do it. That's going to show up in his OpenSea. There we go. So this is the Polygon NFT example in Scaffold Eth. Hopefully I took you through the full run of building and deploying, and we had some problems along the way, but we solved them. Yeah, Steve, should we open it up for questions? What's the next step here?
Yeah, thank you for such a exciting sharing of Scaffold.eth. I think it's super fun and super useful for developers to leverage from. Yeah, there are actually several questions.
Awesome.
Actually, one of them is that probably the first one is a lot of developers are asking whether this can be integrated with the mobile sector. Like can they build really cool dApps on the mobile devices using Scaffold? That's like one of their questions.
Yep. So I think that my disclaimer there is I build all my things in web apps and I just have web apps. So this is a punk wallet. This is something that I built here. Let me actually quit sharing my screen for a second. We can go big screen here. So this is an app. This is a punk wallet built with Scaffold Eth. And you notice that when I hit send, oh no, that's me. It's just my camera. That's not what I wanted. When I pull up my wallet here, it's going to look like the same wallet. When I do a send, it's going to look like the same send. So all of this is Scaffold Eth, but I'm just using a web browser on my mobile, and that works fine. Like that. And what you'll do is if I want to connect, there's like a kind of a connect button in the top right there. If I hit connect, it's going to give me the wallet connect stuff, right? So I can connect my Rainbow, I can connect my Argent, I can connect any of my wallets to this nice web version. Now, I think that if you want to get in and build React native mobile apps, you can port a lot of these libraries to React Native. But I would say in the beginning, you're just prototyping, man. Get something on it. We can in the time that we took here, I could have deployed this thing. I could have done a Yarn build and a Yarn S3 or a Yarn IPFS, and it would take this whole app and it would put it out on IPFS or out on a static site. Oh, I'm not sharing my screen. Let me share my screen, type that again. I could do a Yarn build and then yarn S3, and that would push this app up to S3 or up to IPFS. And this static app would be available. I can open up my phone and I can access it. So in the amount of time that we took here today, you can build a simple app and you can deploy it to just a web server and use the web server to access it on your mobile device. And it will work with Wallet Connect and MetaMask Mobile and Rainbow and some of those other ones. But if you want to go like hardcore React Native, these libraries are available. You just will have to do a lot more work to port it in and make that mobile experience. But by the time you're building a mobile device or a mobile experience, like you're very sure about how you want everything to go and you want that UX to be very, very smooth. We have deployed plenty of production level apps. Like Nifty Inc. is probably one of the best production level Scaffold Eth apps. And it works great on mobile. Like if you pull up a tablet, like an iPad, and you just go to nifty.inc, you've got burner wallets, you've got meta transactions, you've got instant artist onboarding, you've got the sidechain UX. So you can build things and deploy things using Scaffold Eth to production, and these things will work well. Subgraph and all that stuff is available for you when you get to it. But if you want to go React Native, it's possible. It just will take more work and more custom. You'll have to spend a lot more time with it. I would suggest prototyping to a web browser for mobile devices. Also, I'm going to give these away. I have like 4 or 5 of these left. If you post your address in the YouTube chat, I will copy paste and send you some of these collectibles, and they will show up in your OpenSea. Okay, what's next question? Let's keep going. What do we got?
Well, that's super cool. So the second question is that what's the best way to test with existing library contracts when switching between chains? Do you make mock contracts like testing Chainlink VRF locally, testnet, mainnet, for example? This is by a developer.
So when I'm not a great builder. Like I'm more of a tool builder and an educator. I built things that go to production and they worked out well, but like this is my way of doing it. Let's see. So what I do is when I'm on localhost and I want to try something out very new, I'll grab the contract and I'll make a mock of it. I'll create a mock of it here in contracts and I'll bring it in and I'll use it. It's the exact same contract on mainnet, but I'm just using it on localhost. So I can do lots of quick and fast, just kind of poking with it and figuring it out. Usually out on a testnet, there's a specific testnet for certain things. Like if you want to do Chainlink stuff, there's maybe Covan. And maybe Covan, I don't know, whatever the testnet is. But like, if you want to test out specifically like Chainlink VRF, there's probably a specific testnet that's the best for that. If you want to test out OpenSea stuff, you'll use Rinkeby, right? So mock contracts locally, then use whatever testnet where they have already deployed their own mocks, right? And then when you're ready to go to master, the best way to do this is to do a yarn fork. So back here when we were running our hard hat node and we had that locally, what you can do is you can do a yarn fork. Let me just zoom way in. And this is going to create a local network, but it's going, there may be something new with 1555. Hard hat deploy again. Hard hat deploy. Wiggle wog. Dang it. You got me twice in one show. Dang it. Okay, so it looks like, oh wait, do I just do -- network hard hat? Wait. If I just read the let's try it. Is that all I need to do? Wiggle wog, come on, brother. Oh wait, what am I doing? Am I deploying this? I just did a yarn fork. I don't even understand. My assumption here is that it forked mainnet and then it deployed my collectible, but that's not what I wanted it to do. I don't know why it did that. Why would it deploy the collectible, Wiggle Wog? I'm doing a fork. Yeah, I'll have to go talk to him about that. But so to zoom in, we're going to do local mocks. We're gonna have it working locally. Just kind of tinker around, make sure it works. Then we're gonna go to test nets. Go to whichever test net that specific. If it's VRF, you'll go to one. If it's OpenSea, you'll go to one. And then do a yarn fork, and you're going to fork mainnet. And basically, you have your own version of mainnet that's forked away that you can make a bunch of changes to. You can even impersonate accounts. And let's see, mainnet fork hard hat, right? There we go. Yeah. So read more about mainnet forking, but basically you have your own little mainnet and you can try and make sure everything's going to work. Like, okay, this does, like, when I do this, it does mint the thing. When I lock it up, it does work. Okay, now I'm ready for real mainnet. Then at that point, you take off your fork, you point your hard hat at mainnet, and you're very interested. And once you do mainnet here, you're very interested in gas. So you probably want to pay attention to what mainnet gas is being used and some other things. But at that point, you deploy to mainnet and it goes. I think that's an okay answer there.
That is, yeah. Thank you. So
did
yeah,
anybody post any addresses yet? I don't see any addresses in the chat. Where are the addresses at?
yeah, guys.
Well, he's not sober. I'm definitely sober. What is it? It's 9:30 a.m. here. I am definitely sober.
Austin is very exciting, and he's
that's right.
So yeah, we can see another question. So he thinks that dev tools are super cool and important public goods. So we can actually see Scaffold Eth on Polygon-Grants. Like, other than this, how's your project funded right now?
That's a great question. So I have something called the Build Guild. So the TLDR is it's funded by me. Basically, like, I got Uniswap drops for having a bunch of burner wallets, and then I got GTC drops for being early and doing a lot of Gitcoin grant stuff. So I just had some crypto that I can pay folks, and so I'm streaming my own ETH to developers to work on Scaffold ETH. But what I found is, as we had those templates, as we had as we saw that people can take a template and make a new starter kit and a new starter kit, and all of a sudden all these starter kits started coming out of Scaffold ETH, I knew I needed to incentivize that. So I created the Build Guild, and it's biddlegiddle.com. It's like the worst domain ever. It's so hard to type in, but I kind of did it on purpose. That's the way it's going to go. But this is the Build Guild, and we build all these generic components for the ecosystem to fork, right? If you're looking for bonding curves or a streaming contract or a lending contract, or this is like a full production website that does signed messages and lets you share those signed messages. Tons and tons and tons of. So I created the Build Guild.
Sorry.
Wait, I could hear you. Oh yeah, making sure the audio work on the stream. It's still working. So the Build Guild is our funding and incentivization layer, and anyone can get in here and say, you know what, these guys are doing great. I'm gonna fund that dude. I'm gonna fund that dude. I'm gonna fund that dude. Check out. Send them an ETH. Send them some guidance. Hit send, and it'll pop up your MetaMask, and you can donate. So you can send money to buildguild.eth, which is our multi-sig here. Or you can send to specific builders, and this is going to their stream. I'm streaming each one of these developers ETH, and then they're turning in their work as they work on things. So if I just go click on, like, Viraz does a ton of work for us. He's built so many cool things, but I can see his stream, then I can see where I've put money in, and then I can see where he's withdrawn, and we can go see what he worked on. Like, what did he, a diamond starter kit, right? How awesome is that? If you checked out the diamond standard, he's got a diamond starter kit here, right? So a starter kit for learning the diamond standard and learning how to, like, plug those modules in and out and kind of create upgradability. Viraz built it, and he turned it into his stream, and he withdrew some funds. So the funding is basically me YOLOing to people right now. If you want to get in and donate, you can donate to buildguild.eth. You can see everyone and what they funded here. Actually, there's been some wow, that is some awesome person threw in 15 grand recently. So hearts to C5B8, whoever you are out there. Thank you for supporting the Build Guild. I promise you that we will put that to good use and build awesome things.
Yeah, that's awesome. Yeah. Like people learning from this workshop today. If you're a developer, make sure you check out scaffolds.eth for all the amazing stuff you can help. And if you want to support Griffith, Austin Griffith, for his amazing project, you can also check out his Build Guild to see how you can contribute or how you can support this whole project. I personally think it's great. is a great one. Yeah.
One other shout I could throw, if it's okay, is the Moonshot Collective. So
totally.
I've teamed up with Kevin Owaki, and we're creating, similar to the Build Guild, kind of a funding structure, a decentralized funding structure for developers building decentralized tools for coordination. So similar to the Build Guild, where we're building generic components, but in the Moonshot Collective in particular, we're building coordination tools. So the first couple tools we've built are actually funding tools to fund the people who built the first tools. And we'll get in and we'll deploy one of those tools to mainnet, and we'll use a vote that uses quadratic funding, and then we'll distribute some funds, and it's all using our own tools. So we're doing a lot of coordination tools and DAO tooling right now. The Gnosis Safe Starter Kit is another one. If you're looking to build something awesome right now that isn't an NFT or DeFi, check out this Gnosis Safe Starter Kit. It's so cool. And the theory here is that a DAO, or a decentralized organization, doesn't need to have a complex smart contract to start. What they need is a good multi-sig and a great front end on top of that. And this is going to help you build a DAO experience that settles to a Gnosis Safe. So check that one out too. Check out the Moonshot Collective if you're a builder that would like to get into building coordination experiments and public goods funding experiments. Build Guild on Gitcoin-Grants is a good way to support us. But most importantly, check out Scaffold Eth. And when you have a friend that's like, "Ooh, Ethereum, I want to get into it," be like, "Bro, Google ETH Dev Speedrun, and you'll get this great speedrun, and it'll take you through the curriculum, and it'll get you started." That's sorry, I had to jump in and give the full so much shilling. I still haven't seen any addresses in the chat either. I'm giving away free NFTs. No one wants them. Too bad.
I think I can see a few here.
Oh, really?
I wonder if
I'm looking at the wrong chat then. Yeah.
Yeah. Well, if anyone just posted and you can see it, I can actually copy paste those addresses, share it with you later. Yeah.
Dope. Awesome. Thank you very much.
Yeah. No worries. I think all the shilling is super, super useful for the developers on whether they want to kickstart their project on Polygon, Ethereum, if they want to join Moonshot Collective to bootstrap their DAO or kick off their project, or to use Scaffold.eth for their project development. I think all of your sharing today can help everyone joining in the Polygon hackathon in general a lot. So very, very happy to host you today, Austin. And thank you for joining us so early from Colorado. Thank
you for having me. Happy Bowtie Friday.
Happy Bowtie Friday. Yeah. Guys, we had a great time with Austin, and we hope to see more of Austin in DoorHacks community later. Let's definitely build cool stuff with what Austin mentioned today. And good luck with happy hacking on Polygon and happy hacking on Ethereum. Yeah.
Thank you for having me. Happy Bowtie Friday. Send me those addresses. I'll send some more of these out if you just hit me in the chat or something.
I will do. All
right. Yeah. See you guys. Thank you. Go build something awesome. Tag me on tag me on Twitter when you build something awesome. See you.
Yeah. Bye guys. Thank you.